Hey there, welcome back to Academy. If you have ever stumbled upon the famous donut tutorial for Blender, you will know how intuitive and fun it can be for beginners. Well, guess what? Today we are bringing that delicious twist to the world of parametric modeling. Let's dive into Grasshopper 3D and model a delicious digital donut. Let's get started. Let's start by turning on Rhino. Once we are in Rhino, we will launch the Grasshopper plugin. We can do that by clicking this button, Launch Grasshopper, or we can write Grasshopper in the command bar. We will press Enter, and it's going to launch the Grasshopper plugin. Now, depending upon how many plugins you have installed within the Grasshopper interface, it can take a couple of seconds to even a couple of minutes. Now, once we have turned on Grasshopper, we will dock the Grasshopper window on the right-hand side of the screen. This is a generic configuration, but if you use two different screens, you can use one screen with Rhino and the other one with Grasshopper. Now, whatever we are going to work within the Grasshopper context, we will see what's happening in our Rhino environment. So I generally prefer to extend the properties menu until here so that there's nothing occluding behind the Grasshopper interface. Let's maximize the perspective viewport by double clicking on it, and let's get started with the donut tutorial. So the first step would be creating a circle, and along the perpendicular frame of the circle, we will create some circles with random radius. And then we will loft these circular profiles together and create the base for the donut. Let's go to the Curve tab, Primitive subtab, and we can create a circle using these components. Now, the one that we will be using will require a plane and a radius value. So this one. So let me click on it and deposit it on the Grasshopper canvas. Now you can see that the circle component looks like this in my case, but in your case it might look slightly different. So you can change the display of the components by going to Display in your Grasshopper environment and then changing that do you want to see the icons or not, and do you want to display the full names or not. Okay, I will recommend you guys to display the full name as well as name of the components. All right, I will draw the icon for the ease of visibility of the component. All right, so the first parameter is going to be plane, which is already set to the world of Rhino 000. The next parameter is the radius. So what is the radius of the donut? Center. So I'm going to define the value by double clicking on the canvas and writing the numerical value 25. And we're going to then connect the number slider to the radius parameter by dragging a cable from number slider to the radius value. So here you can see we have a circle with a radius of 25. And you can see if I change the number slider, the radius changes as well. The next step is to create perpendicular frames on that curve. So we can go to the Division tab within the Curve subtab and create perpendicular frames on that circle. So let's create this component, connect the circle component in the curve input, and you can see that it is creating these perpendicular frames on the circle. And I can choose how many frames that I need. So let me say if I need 12. So I can change the number of frames to create the new circles. All right, so once we have these 12 frames, I'm going to create another circle component so that we can create new circles on these frames. So you can go to curves, primitive, circles, and connect the frame output for the planes for the circles. And you can see these circles are drawn. Let me change the radius. Let's say, what if we change the radius to 15 units? All right, so here you can see we have these different circles with that radius. Now at the moment, we have a uniform radius for all the circles. We will be changing it to slightly different radius for each of these circles so that we get this organic look in the donut. Now once we have these circles, we will loft these cross sections into a single surface. All right, so in order to create that surface, let's go to the Surface tab, Freeform, Loft. Okay, now we're going to use these circles, these curves, and loft them together. And here you can see we have a lofted surface using these circular cross-section profiles. Now, of course, you can see the first and the last cross-sections are not connected. So we have to change that option, which you can do by creating a new component for loft options. Connect the options to the option input. And here you can see the closed input by default is set to false. So I'm going to change that status to true. We want the loft to be closed. So in order to change that status, you have to create a Boolean toggle. Okay, so let's double click and look for a component called Boolean toggle. Okay, so let's connect it here and double click on it, and we can make the loft a closed loft. Alright, so once we have the loft, we now need to create random values for the circles. As you can see, we have 12 frames or 12 circles. Now instead of using one radius, we need 12 random radiuses. In order to do that, we will be using a random number generator. You can do that by going to Sets, Sequences, and here you will find a component called Random, which helps you generate random values between a certain and a certain number. So let's create this component, and this component is looking for 3 parameters. What is the range? So what is the minimum and maximum value of the random number? How many random numbers do we need? And a random seed in case you want to create variations in the random number. Okay, so in this case, we would need equal number of random values as there are frames or circles. So rather than creating a new number parameter, I'm going to use the same one that we have already defined. Okay, in order to define the range, so what is the lowest and the highest radius for the circles, we will be creating a domain because that parameter is a domain parameter. Okay, so let's go to Maths, Domain, Construct Domain. All right, so in this component, we can tell what should be the lowest number for the radius and what should be the highest number for the radius. And this component will create an instruction for this component so that it can generate those 12 random values. Okay, so I'm going to set the lowest radius to, let's say, 14 units and the highest to 16 units. Okay, so in the random component, you can see we have 12 random values between 14 units and 16 units. Okay, so rather than using a fixed value for the radius, I'm going to substitute it. So you can either delete it or directly connect the other component as the new radius parameters. So here you can see we have a shape with a varied radius, and we have that organic look in the donut shape. Now, before we proceed to the next steps, It's really important in Grasshopper to keep the canvas neat and clean. So I will rearrange the components to create a better layout. So let's move everything towards the center. Let me align these components to the other components, and you will notice that the components snap when the cable is straight. You can also right click on the number slider and change the parameter name. So this is cross sections. You can right click the radius and these components as well, min and max. Okay, I will move the loft component towards the upside because we need these circles for the next step. So I'm gonna take all of these components and move it up. So this is the new layout that we need for the next step. You can also use these align tools to align the components parallel to each other, center the line, or distribute uniformly. Great, so let's go to the next step. Great, so now we have the donut base shape, and now we need to create the icing on top of it. So for the icing part, what we will do is we will select these circles and create a point on all of these circles. Okay, we can choose where the point is gonna be, and we're gonna connect all these points together to create a curve, which we will use to part this base donut into two halves. Okay, now rather than using a fixed place for the point, we're gonna randomize the displacement of the point across the circle. All right, so let's see how can we do that. Great, so what I will do first is hide these components. So I'm gonna select them all together by drawing a rectangle, pressing the middle mouse button, and it's gonna give us the radial menu. So in the radial menu, you can see that you have the option to enable the preview of a component or disable it. It's really important in Grasshopper that you keep on disabling the preview of the previous components, as generally you will be modeling one geometry on top of another geometry. It's important that you hide the previous geometries, or else you will get confused. All right, so you can select the components, middle mouse button, enable the preview, or middle mouse button, disable the preview. All right, so let's see how can we create the random points on these circles. So the first thing that we will need is a new component called evaluate curve. So we can go to the curve tab, analysis, and use the component called evaluate curve. Okay, so this component requires the curves that we would like to evaluate and a parameter. The parameter of a curve is basically a domain between 0 and other number, and the curve parameter can vary based upon its length, its number of control points, its degree, and other characteristics. For these circles, we don't know what the parameter is, but we can check it by creating a curve domain component. Let me connect the circles here. And at the domain output, I can see that the domain of these curves goes somewhere from 0 to 97, 87 or something. So we want to standardize these domains, these parameters of the circles. So we can do that by right-clicking here and reparameterizing it. Or let me right-click here and reparameterize it, and you can see the domain are now standardized between 0 and 1. Let me get rid of this component. So if I provide any number between 0 and 1, let's say 0.5, I'm able to extract a point anywhere on the curve between 0 and 1. Okay, Now, rather than using a fixed value, we will use some random set of values for the parameter. Just like the initial step of creating random circles, we need random parameters. So we need a similar instruction to this, but now the domain start would be 0, domain end would be 1, so that we can create these points between 0 and 1 parameter. So let me recreate the random component, sets, sequence, random. We need the same number of random values as we have number of circles or number of points. So we are going to use the same number from cross section. We need the domain between 0 and 1. I can also technically copy these 3 components, Control C, Control V, and use it here. So the range is going to be between 0 and 1. Okay, so you can see we have random numbers between 0 and 1. Let me connect it here, and you can see we have points all across the donut in a random way. Now let me create a curve using these points. So in order to create the curve, we will be using the interpolate curve command. Curve, splines, interpolate. So it's going to take all of these points and create a curve connecting those points. We also want to make this curve closed. So let me just change the periodic parameter to true value. So we will use the same Boolean toggle, periodic, true. So here you can see we have a curve connecting these points. Now, of course, we don't want the icing to be that random. Okay, we would limit the value for the randomness between, let's say, 30% of the curve to 40% of the curve. So rather than using these numbers 0 to 1 for the random values, we're going to set it to, let's say, 0.3 to 0.4. We can also further calibrate it. So now you can see we are able to create this cross section for icing at the top. So let me calibrate it to 0.45 to 0.55. Right, so the icing is going to be around this top half. Just like in the previous steps, we will hide the unnecessary components. Select them all, middle mouse button, hide. Right, so we have the loft on one hand, and we have the curve that we will use to split the loft in 2 halves. So in order to split the lofted surface, we will use the split surface command. So let's double click and write split surface. And you will find this component. This is the surface to split, and this is the curve used to split the surface. Let me hide the original loft for a moment. As you can see, it's interfering with the new splitted surfaces. Select it, middle mouse button, hide. So here you can see at the output we have the 2 halves of the splitted geometry. We can extract one of it out of the list by using a tool called list item. Okay, this tool helps you retrieve an item from a list. So in this case, we have a list of 2 surfaces. Right, so in coding language, the first item is always index 0 and the second item is index 1. So if you want the bottom half, you set the index to 0, the top half index 1. Don't forget to hide the previous components, or else you will see the overlapping geometries. Now, once we have the icing part split up, this particular geometry is a surface. It has no thickness. So in order to give it thickness, we have to offset that surface. Now, in the native Grasshopper plugin, we have an offset component, offset surface. However, this component is not gonna give you a solid geometry at the output. Okay, we can download other plugins which can give us the solid offset, but let me show you how can you create your own custom component using a Python script in Grasshopper. So we're gonna go to Maths tab, Script, GH Python script. Okay, so we will use the Python script to create a simple script that is gonna take a surface, offset it, and make it solid. So let's see how can we do that. So once you have created the Python script component, in order to edit the script, you have to double click on it and it's gonna pop up this window. Okay, as you can see, it has a lot of already set up details. We can get rid of it. You can also use the control button and scroll your mouse wheel to make the text bigger or smaller. And basically what we are doing is we are already importing the Rhino script syntax, kind of like the Rhino library, as RS. Okay, we have two inputs, X and Y, and two outputs. The textual output, whichever you see here, is that output, and another data output called A. So basically, let me press enter to add a white space. We're gonna set it to A, which is the output, equals, let's call the Rhino script syntax library. So I'm gonna write RS dot. So it is gonna recommend me all the possible commands that we can execute with the Rhino script syntax. So let's look for offset. So you have these offset components and we're gonna look for offset surface. So let's click on it and one more time. Okay, so we are calling that the A output is going to be the Rhino script syntax and the offset surface command. Now to define the parameters, we have to open a bracket. And here you can see at the bottom, it's telling me what are the parameters set up for. So the first parameter is going to be the surface. The second is what is the distance for the offset. And the third is tolerance. So in this case, it's predefined none. Both sides, it's set to false. So we don't want to do an asymmetrical offset. And create solid, that is also set to false. However, we want to make this parameter true. So you can technically copy this entire part, Control C, and paste it here. Okay, so the surface ID is X, that's the surface. The distance is Y. We're going to define in the Y value the surface offset distance. Tolerance is none. In this case, yes, we're going to set a tolerance of, let's say, 0.001 millimeter. Both sides is set to false. So I'm going to set that to false as well. So we can leave it as it is or write 0. 0 is false. And create solid, we want to make it true. So let's write 1 and close the bracket. So here you can see we have defined the component. So let's press OK. Now the component by default is red in color. Let me connect the item output for the surface input in X. And let's define the distance value in Y, 2 millimeters. And here you can see we have offsetted that surface as a solid geometry using the Python script. You can change the thickness. I'm going to set it to 1 millimeter. And at the A output, you can see we have a closed geometry. So now we have the icing on top. We have the base donut geometry. And now we are going to add sprinkles on top of the icing. Let's see how can we do that. So to add the sprinkles, let's first extract the very top surface of this solid geometry. So let me hide the base loft. Let me explode the poly surface. So the explode command in Grasshopper is called deconstruct. And in this case, we are deconstructing a poly surface, also known as B-wrap. So let's look for deconstruct B-wrap. Connect the A output. Okay, be careful, not the top one, the bottom one, because that is where we are outputting our closed geometry. All right, let me hide this. Now we only need the very top surface, because as you can see, we have approximately 4 surfaces at the output. Yeah, there you go. So just like the previous example, we can use the list item component to extract one item from the list. So let's go to sets, list item, connect the faces here, and we can start with index number 3. That's the 4th item. So that is the 4th, this is the 3rd, this is the 2nd, and this is the 1st. So index 0 is the outermost surface. So we need that. Now we will create some random points on this surface. So to create a random point on a geometry, you will be using a tool called populate geometry. So vectors, grid, populate geometry. Connect the geometry here, and there you go. You can see we are depositing random points on the surface. We can choose how many random points do we want on the surface by double clicking and defining the count parameter. Let's see, 200 points. You can define this number as per your computer spec. You might see that it takes quite some time, especially for the next step when we will convert these points into pipes. So be careful with the number slider here. So you may start with some less number of iterations and then increase the number later on. All right, so in order to create the sprinkles, we have to first convert these points into lines. Okay, and the lines, we're gonna randomly orient them in some vector, and then we're gonna pull these lines on top of the donut. So in order to create lines starting from the point, we will create this component called line SDL. Okay, this component will create a line using a start point, some direction. So in this case, you can see a default direction is z-axis. It's creating a line pointing upwards, and you can define a length. So what is the length of that line? You can see by default it's just going up. So we have to create some random directions in the X and Y plane in Rhino. We need to create a random vector, which we can do by going to the vector subtab, create a vector in the XYZ axis. Now we need 200 vectors for these 200 lines, and we need these vectors to be random. So let me create random numbers using the same strategy. Random component. We need a range. So the range is going to be between +1 and -1, which means that the line can go this way or the other way. The same in the y-axis, this way or the other way. So we are able to create a line in all the 360 degrees starting from the center. Okay, so let me create the domain component, and the domain is going to be starting from -1 to +1. So let me set the max Now in order to define a negative number slider, we can just add a negative component which converts any number into negative. Okay, so here you can see we have a domain going from -1 to +1. So let me rearrange the components. There we go. We need equal number of random values as the number of points, and that is basically the random vector in the x direction. Let's connect the vector to the direction so that you can see some of the lines are going this way, some of them are going the other way. Now let me create another of this component, the random one. Okay, you can also Control C and Control V. The range is also going to be +1 to -1, the same number of random values, but for the y parameter. Okay, now you can see that these two random components are generating exactly the same number, and the reason for that is in Grasshopper random component, it's not actually a true random value. There is a mathematical expression within this component which creates this random number. Okay, so in order for this component to create a new set of random numbers, you have to modify the seed parameter. Okay, so you can write any number here, and as you can see, whenever you modify it, you can get a new random distribution. Okay, now the length of the sprinkles is going to be less, so rather than 10 millimeters, it's going to be 3. And here we have all the random lines on top of the surface. The same seed parameter can be modified here if you want a new distribution of points. Okay, as you can see here, when I change the number, we get a new set of distribution. So you can calibrate it as per your requirement. Now we're gonna pull these lines to that surface. Okay, so let me move it here. So let's run the pull curve command. These are the curves to pull. This is the surface to which we have to pull the lines. Okay, so here you can see that we have pulled these straight lines on that curved surface. We need to hide the previous components, just like every time. And there we have the curves on top of the surface. Now we need to convert these curves, these pulled lines, into pipes. So let me create a pipe component. Curves. And you can see by default the radius is quite high for the pipes. So let me set the radius to, let's say, 0.6. You can change the size of the sprinkles as per your requirement. And you can also change the end cap of the pipes. So here you can see 0 means no cap, 1 is flat cap, and 2 is round cap. So let me create a number slider with the value 2, and we have a round cap here. Be careful, it might take some time, and you might also notice some artifacts like these, so that could be the reason of a random distribution. So you might want to calibrate it by changing the random seed value of one of these components or the populate component as well. So here I can see I have a better distribution, and I'm gonna stick to that. Great, so we have the base donut. We have the offsetted surface, and we have the sprinkles here. Okay, so let me hide everything else except these three components. You can also use the middle mouse button and group it so that you have this colorful grouping icon across the component. This is going to help you identify the component from far away in the script. Now we're going to correct the visualization of these geometries. In order to create a better visualization, we can use this additional display component called custom preview. Okay, and you can see this component is a bit weird because it doesn't have a geometrical output. Its output is a visual output. So let me connect the pipe to the geometry input. And you can see we are coloring these pipes with that color, which is a default pink color. You can hide the previous node. And in order to change the color, you can go to primitive and create a color swatch. You can change the material color here to any of these colors. Let me add the custom preview to the icing as well, which is this component. So let's create a custom preview. A output, you can hide this node and color swatch to define the color. So the icing is going to be a pink color or any other icing as per your preference. And for the base, let me create one more custom preview. Hide the previous component, color swatch, and define the color of that geometry as well. Okay, and here you can see we have modeled a donut in Grasshopper. So there you go. We have modeled a donut from scratch in our Grasshopper environment. And not just that, we can change these values and create new variations of the donuts. So for example, if I want the donut to be a bit bigger, I can go to the very beginning of the script and change the radius to 30 units. And you can see we have a different donut. I can make it smaller. Okay, you have to calibrate it once you generate the new radius. You might want to change the number of points or also change the random seed value. And there you have it, a digital, delicious 3D donut, all modeled in Grasshopper 3D. If you followed along, congratulations on creating very first Grasshopper script. But remember, it's just the beginning of the vast world of parametric modeling. If you'd like to learn more and you're a professional designer, we have got exciting news for you. We are offering a Grasshopper masterclass where we will dive deep into the world of parametric modeling. It is tailored specifically for beginners and intermediate users. If you are an advanced user, you can also join our advanced parametric texture workshop, specifically tailored to create a vast variety of parametric textures for your design projects. You can find the link in description. Thank you for watching and see you guys in the next one. Take care.